Welcome to Animated Maths for All, Series 2. In this video, we aim to help you learn, grow, and excel in mathematics. This video will explore some key concepts in volume and surface area. Hello, students. Let's start by recalling the formulas for finding the volume of cubes and cuboids. You've applied these formulas previously. Now find the volume of these two solids, a cube with a side of 4 centimeters and a cuboid with dimensions 8 by 4 by 2 centimeters. Once you've found the volumes, compare the steps you took and the answers you obtained. Let's review the steps and answers for the cube and cuboid. For the cube, the volume is side cubed, which is 4 cubed, resulting in 64 cubic centimeters. For the cuboid, the volume is length times breadth times height, which is 8 times 4 times 2, also giving 64 cubic centimeters. Did you notice that a cube and a cuboid, despite having different dimensions, can have the exact same volume? This illustrates that different shapes can hold the same amount of space. Now, consider this new cuboid with a height of 1 centimeter. Find its volume using the same method. Remember to use the formula, volume equals length times breadth times height, for this new cuboid. We see the new cuboid has dimensions 8 by 8 by 1 centimeters, resulting in a volume of 64 cubic centimeters. You can see many solids can have the same volume. Let's work on another problem. Recall that volume also equals base area multiplied by height. Now, find the volume of these two solids. Solid A has a base area of 21 square centimeters and a height of 5 centimeters. Solid B has a base area of 9 square centimeters and a height of 7 centimeters. For tank A, the volume is 21 square centimeters times 5 centimeters, which is 105 cubic centimeters. For tank B, the volume is 9 square centimeters times 7 centimeters, which is 63 cubic centimeters. Volume units are cubic centimeters. Now, let's look at another example. Consider this large cube with a side length of 5 centimeters. The base area is 25 square centimeters and the height is 5 centimeters. Use the formula, volume equals base area times height, to find the volume of this big cube. This big cube is made up of smaller 1 centimeter cubes. Find the volume of this big cube. Yes, the volume is 25 square centimeters multiplied by 5 centimeters, which equals 125 cubic centimeters. Excellent job. Now, let's find the total number of 1 centimeter cubes that make up this 5 by 5 by 5 centimeter cube. The big cube is a 5 by 5 by 5 centimeter cube. The number of small cubes is 5 times 5 times 5, which is 125 cubes. This confirms the volume is 125 cubic centimeters. Now, look at the working. The volume is indeed the number of unit cubes contained in the solid. What happens if we remove 4 of the small 1 centimeter cubes from the corners of the top layer? Find the volume of the remaining solid. Let's observe the remaining solid. Look at the working to find the new volume. The volume of the big cube was 125 cubic centimeters. The volume of the 4 small cubes removed is 4 times 1 cubic centimeter, which is 4 cubic centimeters. Therefore, the volume of the remaining solid is 125 minus 4, which is 121 cubic centimeters. Now, consider this new large solid, which is a cuboid with dimensions 5 by 5 by 3 centimeters. Do you think the total volume of the cubes inside will be equal to the total volume of the bigger cuboid? The dimensions are 5 centimeters by 5 centimeters by 3 centimeters. What do you think, John? The volume of the big cuboid is 5 times 5 times 3, which is 75 cubic centimeters. No, there is some more space in the outer cube, which is the internal volume or capacity. In this case, they are the same. Excellent, John. However, note the reason on the board. The cubes are not tightly arranged, and the total volume of the 1 centimeter cubes will be less than the volume of the outer cube. Now consider this tank filled with water to the brim. Will the volume of the water be equal to the volume of the tank? Consider the characteristics of water, a liquid that takes the shape of its container. Yes, when filled to the brim, the volume of the water is equal to the internal volume or capacity of the tank. If the dimensions of the tank are length 7 centimeters, breadth 3 centimeters, and height 7 centimeters, what is the volume of the water? Remember to use the formula for volume, length times breadth times height. Correct! With a length of 7 centimeters, breadth of 3 centimeters, and height of 7 centimeters, the volume is 7 times 3 times 7, which equals 147 cubic centimeters. As the water takes the shape of the container and is filled to the brim, the volume of water is the same as the volume of the tank. We will learn more in the next session. We have seen that liquids like water take the shape of their container, and their volume equals the container's capacity when full. Thank you for watching this video. We hope you learned more about volume and capacity.